Hello guys, welcome to my channel once again. This is the second video under this page, and to my 21 subscribers, thank you so much guys for subscribing. And for those who haven't subscribed yet, it's not too late. Please do click on the subscribe button, because you know subscribing means you will be able to get notifications whenever I post videos. And remember, my comment section is also opened, so please guys feel free to interact with me. Tell me what you would like me to cover next. Tell me the chapters that you find challenging, and believe me, I will definitely create some videos to help make things simple for you. For today's videos, we are continuing with the nature of roots. I have posted the first part of the nature of roots, where I am outlining the nature of roots, and on this one we will be covering the questions under this chapter on how to apply the nature of roots to answer different types of questions that you can get tested on. Guys, get your pen, get your paper, get your calculator, sit down and relax, and feel free to pause, do the question, then continue to check if you got it correct. That can work. That will help you practice. So the first question, we have given that f at x is x squared minus 2px plus 8 plus 2p has two equal roots where p is less than 0. Determine the coordinates of the turning point of h if h at x is f at x minus 3. Okay, this one it looks a bit long because now they are taking us to a turning point, but guys, don't worry, I've got you covered. So we've been given the story about the nature of roots, but they want the turning point. So starting with the turning point, we know in the parabola, to find the turning point, we use the formula x is equals to negative b over 2a. Then the x value that we get there, we take it, we substitute it on f at x to get the y value. Okay, the y coordinate. So yeah, you can go straight and find b, you can find a, but the problem is there is this p that is standing on our way. How are we going to calculate x when there's a p? It means we have to first find p. Since they've given us the roots, we are going to find the value of p in which that equation has two equal roots. What do we know about equal roots, guys? Equal roots, if you have watched the first video, you would have seen that equal roots means delta equals to 0, and remember delta is b squared minus 4ac. We equate it to 0, so b squared minus 4ac is equals to 0. So we need to go to our main equation and extract b, extract a, and extract c. So also from the first video, I did highlight that in order for you to find your a, you will look for the coefficient of x squared. The value or whatever is in front of x to the power of 2, it's going to be your a. Whatever is in front of just x, it's going to be your b. And whatever doesn't have any x next to it, it's going to be our c. Meaning if we go back there, x squared has a coefficient of 1, so our a is 1. B squared has a coefficient of, just b, or x has a coefficient of negative 2p, which make this our b. And we only have 8 plus 2p left, which makes it c. So now it means that our b is going to be negative 2p squared minus 4. Our a is going to be 1. Our c is going to be 8 plus 2p equals to 0. So now we have managed to make use of two equal roots, meaning we are going to look for the value of p minus 2p squared. It's just positive 4p squared. Remember guys, when you substitute, you must put it in a bracket before you square it, before you give it an exponent 2. So we have positive p squared, negative 4 times 1, it's negative 4, negative 4 times 8, it's negative, what is 4 times 8? It's going to be negative 32. The negative 4 times 1 is negative 4. Negative 4 times positive 2p, it's negative 8p equals to 0. So now we have a quadratic. We are looking for the value of p, but our 4 has a coefficient of, our p has a coefficient of 4, our p squared, meaning we can divide everything by 4, by 4, by 4. Then we are left with p squared minus 32 divided by 4. It's going to be 8, I think. Yes, 32 divided by 4 is 8. And then negative 8 divided by 4 would be negative 2p equals to 0. I'm rewriting that as a quadratic minus 2p as the standard quadratic form. Then we can now factorize, guys, the factors of negative 8 that gives us, that adds up to negative 2. That has to be 4 and 2. So we have a 4 there and a 2 there, and then our 4 has to be negative, the 2 has to be positive, equals to 0, meaning p is equals to 4 or p equals to negative 2. So remember, we said we are looking for the value of p, but we end up with 2 p values. Now how do we decide which one to use, guys? How do we decide which one? Are we using positive 4 or negative 2? Let us go back and look what else did they tell us. They had said that, okay, that f at x has 2 equal roots and p is less than 0. We are only working with the p that is negative, meaning we are kicking that one out. Therefore, our p is equals to negative 2. Negative 2. Now we have found the value of p, meaning we can substitute p there, so that we have now a normal quadratic equation of a parabola that we can make use of there. So I'm going to substitute the p value. So our f at x is x squared minus 2px minus 2px plus 8 plus 2b plus 8 plus 2p. Substituting my p, I have p2 minus 2x plus 8 plus 2 minus 2. And now I'm left with x squared plus 4x plus 8 minus, not minus 2 but minus 4, because positive 2 times negative 2, it's negative 4. Now my quadratic is x squared plus 4x, 8 minus 4 plus 4. That is my f at x. Okay, now I've managed to get that equation that was having p's to be a normal quadratic that I can use to find my turning point. But remember, we are looking for the turning point of h, not f. But when h at x is equals to f at x minus 3, so they are saying h at x is f at x minus 3, and our f at x is x squared plus 4x plus 4 minus 3. Okay, so it means now our equation for h at x is going to be x squared plus 4x, 4 minus 3 is plus 1. There we have our h at x. We can find the value of the turning point minus b over 2a, and that's going to be minus 4 over 2 times 1, and 2 times 1 is just positive 2, so that's going to be negative 2. Then now we have to substitute it back to h at x to find the y value. So we have negative 2 squared plus 4 negative 2 plus 1, which is now going to be 4 negative 8 plus 1. So 4 plus negative 4 negative 8, it's negative 4. Negative 4 plus 1, I'm gonna plug that on my calculator, guys. It's best to not make mistakes. So the calculator is there, plug it, let's plug it and get the correct value. So it means our turning point is -2 and -3. Okay guys, this is it with the first question. Quite long, I think it was worth 5-6 marks, but you just have to use what we know about equal roots and what we know about a turning point. Don't panic. You are looking for a turning point. You know your story about the turning point, and if you know your story about a turning point, you have a P that is a barrier there. It's stopping you from substituting your B and your A. So use the equal roots to find a value for P so that you can sub it in there, and now it's gone. You have numbers and x's. Then you are able to use your turning point equation. Okay, I hope you guys did understand this. Please don't forget to interact. Tell me on the comment section if you need clarity with anything. I am open to replying to that. Now we are going to the second question. Given 2mx squared minus open bracket m minus 2x plus m plus 1 equals to 0, where m is never equals to 0. Determine the values of m for which the equation has real roots. So firstly, we need to check, is this equation in standard form? I mean, is it ax squared? Remember standard form, guys, it's ax squared plus bx plus c is equals to 0. So yes, we see we have equated it to 0. We have 2mx squared minus m minus 2x plus m plus 1. It is in standard form. Now we can try and remember, what do we know about real roots? Okay, so with real roots, we know that our delta, it's either greater than or equals to 0. Just real roots. However, they say m must never be equals to 0, meaning we cannot use the equal. We are only using delta. It's greater than 0. I hope you are still with me, guys. So our delta is b squared minus 4ac equals to, no, not equals to, but greater than 0. So now let us extract our b. So we had said b must just be in front of x. Whatever is in front of just x is b, meaning our b, it's negative m minus 2. So I'm going to put negative m minus 2, close bracket, close another bracket, squared minus 4. Our a, whatever is in front of x squared, meaning our 2m represents a, so a is 2m. And our c, anything else that is left that doesn't have x is part of c, m plus 1. It's greater than 0. So I'm just gonna multiply the square root, the exponent 2 in. Remember, guys, exponent gets rid of it removes the negative. So I'm just gonna have m minus 2 squared. This, guys, is from the fact that when you have negative 2 squared, the answer is just positive 4, not negative 4. When you have negative x squared, the answer is just x squared. So an exponent 2 removes a negative. That works for every exponent that is an even number. M minus 2 squared minus, I'm going to multiply the 4 and the 2m. I have minus 8m, and I still have m plus 1. It's greater than 0. And that I'm going to FOIL out. So I have m minus 2, m minus 2. Then also the 8 times m, it's going to be 8m squared. And the negative 8m times 1 is going to be negative 8m. It's greater than 0. m minus 2 filed out is going to be m squared minus 4m plus 4 negative 8m squared negative 8m. It's greater than 0. Then we can find our like terms. We have m minus 8m squared. That's going to be negative 7m squared. Negative 4m, negative 8. It's going to be negative 12m. Then we also have a 4 there plus a 4. It's greater than or equals to, it's just greater than 0, not equated, just greater than 0. We can find the factors directly, or we can get rid of the negative. Let's make our quadratic positive, meaning I'm going to divide everything by, I'm going to take out a negative outside of a bracket so that I have 7m squared plus 12m minus 4. It's greater than 0. And I just divide that by negative 1. Remember, if I'm taking out a negative 1, let me just take back my words. I took out a negative 1. I'm also dividing with the negative 1. So remember, guys, in inequalities, if you find yourself dividing or multiplying by a negative number, you reverse the inequality. You reverse the inequality. So I have divided with a negative 1, meaning my inequality has to now be reversed to less than. So I have now 7m squared. I'm just gonna put it negative 4, no, plus 12m, sorry, 7m squared plus 12m minus 4. It's now less than 0. Please, guys, this is very, very important. If you choose to get rid of the minus in front of your coefficient of m squared, the inequality must be reversed. That's a law for working with inequalities. So now I can use a quadratic equation to find my values of m. So for my quadratic equation, I have minus 12 plus or minus square root of 12 squared minus 4 times 7 times negative 4. Guys, this is from a quadratic formula. We have it on the formula sheet. Please have a look at it. Divided by 2 times a, which is 7. The values of m are going to be, I'm just going to plug that on my calculator. So I have negative 12 plus square root of 12 squared minus, I should close the bracket, minus 4, 7, minus 4 again because of my c, it's negative 4, divided by 2. My a is 7. So I have two, my first x value can be 7 over 2, or the second one can be negative 2. Please, guys, take note, I'm leaving the gaps, because remember, when we have a quadratic and you need to put the correct inequality sign, you need to use critical points. I'm gonna jump into critical points. So we are working with a positive quadratic or a positive parabola, and our critical points are 7 over 2 and negative 2. So I'm going to draw a positive parabola graph, and I have negative 2 there, I have 7 over 2, and we are looking for when it is less than 0, meaning I am now working with that portion. So it means when x is between negative 2 and 7 over 2. And remember, now if it's between, you can write it as a single inequality. Hence I'm taking away that now, and I'm saying x is less than, no, x is greater than -2 or less than 7/2. So those are my two x values, and we have answered the question, because the question, no, not x, guys, let's go back, m, because we are working with m, not x. Those are my two m values, because the question was looking for the values of m, the value or the values of m for which the roots, the graph, the equation has real roots. So this is when m is less than, is greater than -2 or less than 7/2. Okay, so the next question we have is, we have to determine the value or values of m for which the equation has two real roots that are opposite in sign, if m is less than 0. Okay, so firstly, let us see, what do they mean when they say if m is less than 0? It means this m there will be a negative value, and that one there and that one there. But our main interest now is, if m is less than 0, it means this m there is going to be negative, which is going to make the whole 2mx squared negative, meaning because it represents a on a parabola, we have a less than 0. So it's going to make this whole part less than 0. So when it comes to answering questions on whether a graph will have opposite signs or the same signs of its x-intercept, I'm just going to draw 4 different graphs to just show what do we look at when we have to determine the values in which the graph will have the same signs or opposite signs of its x-intercepts. We are working with a negative graph because of m is less than 0. So you can have a graph that has, I'm going to start with the graphs which have the x-intercepts that are of the same sign, meaning maybe they are both positive or both negative. So we are looking at a negative graph. You can either have the graph to look like that, or you can either have the graph to look like that. In both cases, here the x-intercepts are both negative, here the x-intercepts are both positive. Okay, and then now what happens now when they say opposite signs? It means one x-intercept is negative, the other one is positive, or vice versa. So let us start with where one is positive and one is negative. Let's say you have something like that, it looks like that, or maybe you have something like that. So in both cases, one x-intercept is negative, the other one is positive, negative, positive. What has changed between same signs and opposite signs? Have a look at these 4 graphs. There's something that is slightly different. Can you spot it? Yes, definitely. The y-intercept there, it's below, it's on the negative y-axis. The y-intercept there, it's above y-axis. Okay, so that is one thing that changes, that makes your graph to either have the same signs of its x, to have its x-intercept to be the same size. Remember, when I say x-intercept, I'm talking about the roots, to either be the same signs or opposite signs. So now it means when they ask you the value of m in which the two roots are going to have opposite sides, we now look at the value for c. Remember, the y-intercept represents c. That is a c. It means we are looking at m plus 1. That is our c. And remember, guys, we are working with a negative graph, a graph that has a negative a. So it means we will say when m plus 1 is positive, it's greater than 0. And here you see it's on the positive y-axis, meaning when m is greater than -1. So for every value where m is greater than -1, that graph is going to have two roots that are opposite inside. Okay, I hope you're still with me, guys. We are now going on to the next question, which is for which values of p will negative 2x squared plus 4x minus 3 equals to negative p have two unequal roots. Unequal roots. What do you know about unequal roots? Unequal roots means delta is greater than 0. This means b squared minus 4ac is greater than 0. But now, how do we get our a, our b, and our c when our equation is not in standard form? We don't have ax squared plus bx plus c equals to 0 for the main equation that is given to us. So I'm going to rearrange it in standard form. So it's going to be negative 2x squared plus 4x minus 3 plus p. Wait, why is it going the other way around? Minus p minus 3 plus p equals to 0. So now I can be able to extract my b. Remember, we had said b must go with x. Just in front of x we have b, that is my b, and then a just in front of x squared, that is my a, and then c, anything else that does not have x, that is my c. So I'm going to substitute my b value, it's 4 squared, minus my a value, it's 4a, my a is negative 2, then c is minus 3 plus p, which I can write as p minus 3, it's greater than 0. 4 squared gives us 16 minus 4 times negative 4 times negative 2, that's going to be 8, positive 8, and I have p minus 3, it's less than 0, so I have 16 plus 8p minus 24, it's greater than 0. Then anything else goes to the other side. I have 8p, it's greater than 24 minus 16. Okay, what is 24 minus 16? That can look better. Okay, 24 minus 16 gives me 8. So 8p is greater than 8. I divide both sides by 8. So when p is greater than 8, that equation is going to have two unequal roots. Okay, I hope you're still with me. And then the next question, they say have the value of p in which it will have roots that are both positive. Roots that are both. This question is similar to the one that we've done above. If they're both positive, it means they need to be on the positive side of the x-axis. So I'm just gonna draw an imaginary graph to show, okay, what are we exactly looking for? So it's a negative 2x squared. So negative 2, it means my a is less than 0. So I'm going to draw a negative graph. Okay, I'm working with a negative graph. So my graph would look something like this. We want to have two positive roots. Here they are. They are both positive. What are we saying? We are saying our c must be less than 0. Our c must be negative. What is our c? We had said our c, it's negative 3 plus p. So it means for the second question, we are saying negative 3 plus p must be less than 0. Therefore, p must be less than 3. So that is the value of p in which those roots are going to be both positive. Guys, I hope you're still with me. I hope you're still following. Please remember, feel free to post on the comments where you need clarity. I'm here to help. Okay, and please remember, if you haven't subscribed, it's still a good chance to subscribe now. You are never late to subscribe, guys. So that would be with that question. So guys, I don't think you would ever experience a problem with this question ever. How do you answer this type of questions? You check, am I working with a positive graph or a negative graph? A negative graph, I know the shape of a negative graph. It's a frown graph. I'm going to draw a negative graph where both the roots are positive, meaning I want them to be there. If they are positive, the y-intercept is definitely on the negative y-axis. Therefore, you're going to say, I want my C, because this is your C. You want that part there, the C, to be less than 0, meaning to be negative. Then you solve for the value of P. Okay, I hope this one has made sense. I'm going to jump onto the next one. I hope you have written everything at this point, because I'm just going to erase to make some space to work on the second question. Okay, yeah, if you haven't written, just rewind, just move a little bit backward and then pause and write. Okay, so the next question for 5 marks, show that the equation p squared plus 1 close bracket x squared equals to negative 2pqx minus q squared has no real roots for p and q being an element of real numbers and q not being equals to 0. Okay, so firstly, what do we expect if we are talking about no real roots? We expect delta to be less than 0, to be negative. So I'm going to rearrange that equation to be in standard form. Already I can see I have x squared there, meaning our p squared plus 1 represents our a, the x squared. I'm gonna move that to the left. It jumps an equal sign, it becomes positive, becomes 2pqx, and that also becomes a positive q to the power of 2 equals to 0. Now we want to show that it has no real roots. We want to show, now guys, we want to prove. So if you prove, it means you're just going to substitute on your delta and see if you're going to get a negative value. If you do get a negative value, it means it has no real roots. So whenever you're proving, you substitute on your delta and check if you have proven. Our b, the coefficient of x is 2pq, so you have 2pq all to the exponent 2 minus 4. Our a, it's p squared plus 1, and then we have plus, no, not plus, but our c is going to be just q squared. So from this point we have 4p squared q squared minus, I'm just going to start multiplying 4 and q. I have 4q squared, and there's p squared plus 1. I hope you are still following, guys. My 4p squared q squared stays as it is, and I have negative 4q squared times p squared. That's gonna be, that is not supposed to be there. That's gonna be negative 4p squared q squared. Alphabetically, I'll start with the p, and then negative times positive is negative. Negative 4q squared times 1, it's just negative 4q squared. So 4p squared q squared minus 4p squared q squared, it would give us a 0. Then I'm left with negative 4q squared. So we would conclude by saying, therefore, delta is less than 0. It means it has no real roots. No real roots. Okay, so that is our final answer. I hope you guys are happy with this. So with this kind of a question, whenever you have to show or to prove the roots, you just substitute your b, your a, and your c on the discriminant to see the value that you get and prove that root. Let us go on to the next question, guys. This is a different type of a question here. We have the solution of a quadratic equation given by x is equals to -2 plus or minus square root of 36 minus 4k over 2k. For which value or values of k will this equation have non-real roots? Okay, so now when they give you a square root, they are giving us the solution of a quadratic. It means this is a quadratic formula. You just need to go and take out your discriminant, and we know, guys, from that original quadratic formula, minus b plus or minus square root of b squared minus 4ac all over 2a. The discriminant is always what is within the square root, meaning even here 36 minus 4k, it's our discriminant. I'm just going to come back here and say our discriminant is 36 minus 4k. That is the value that represents our discriminant. Every time when there's a value under the square root on the quadratic formula, even though it's not b squared minus 4ac, as long as it's under a square root, it represents your delta. Okay, so have non-real roots. We know with non-real roots, delta is less than 0. So we have 36 minus 4k, it's less than 0, minus 4k, it's less than minus 36. And then this is supposed to be a k there, then k. Now I'm going to divide by minus 4. Remember, guys, when you divide with a negative, you reverse your inequality. It becomes greater than negative 36 over negative 4, and your k is now greater than negative 36 divided by 4. That should be negative 9. So when positive 9, because it's negative divided by negative. So when k is greater than 9, your discriminant is going to have non-real roots. It doesn't exist. It will not exist. Okay, now for which values of k will this equation, that whole equation, be undefined? So in order for it to be undefined, it means now we want the entire thing, we want the entire fraction to give you an error on your calculator to not exist. So undefined, we can now look at the denominator. Guys, remember, whenever you have a fraction, every fraction that has a denominator of 0, it's undefined. It gives you a math error. You can plug it on your calculator. You can say 5 divided by 0, you'll get a math error. So every time when they give you a fraction and they say what is the value of a certain, maybe a value of k or value of x, in which the fraction will be undefined, you will say when the denominator is 0, meaning when k is 0. That is the second question. Undefined, if you have a fraction, your k, your denominator must be 0. Not your k, but your denominator must be 0. Okay, I hope you are happy with this one. Let's go to the next one. Show that the quadratic equation x squared plus px squared plus 2px plus p equals to 1 has two distinct real roots for all real values of the constant p, except for one value which must be stated. This is 3 marks. So we want to show that it has two distinct real roots. So it's not in standard form because it's not equated to 0. I'm going to rewrite it and just equate it to 0. Plus 2px plus p minus 1. Now it's equated to 0. And then I have 2x squared. Like I have two x's that have the exponent 2. So I can write it as 1 plus p x squared plus 2px plus p minus 1 is 0. Because we want to show, remember, if you are showing, you are saying delta is equals to b squared minus 4ac. Meaning for our b is, so now that we are showing, we are going to substitute our b, our a and our c. So b is 2p squared minus 4, a is 1 plus p, c is p minus 1. 2p squared is going to be 4p squared minus 4. I'm going to FOIL 1 plus p, p minus 1. That's the difference of two squares, so it's going to be p squared minus 1. And I now have 4p squared minus 4p squared plus 4. And my delta is now 4p minus 4p. It's going to be 0. Then I have 4p. Just 4, not 4p. I have just 4. My delta is 4. And we had to show that it has two distinct real roots for all real values of the constant p, except for one value which must be stated. So if you think about a quadratic, we don't want this part to be 0. So just think about it. If 1 plus p is 0, you're going to have 0 times x squared, and that's going to be 0. So we don't have a quadratic anymore. So therefore, because they said we must state a condition, we will say the condition is that 1 plus p must never be equals to 0, meaning p must never be equals to -1. Yeah, p must never be equals to -1. I hope you're still with me, guys. So guys, this would be the final answer, and this is the last question under these questions from the nature of roots. I hope you guys can get as many past papers as you can, and just look for more questions on the nature of roots and see now how it is when you do it just after watching the lesson. I hope you now have a picture of how you can differently answer the questions under the nature of the roots, and also what exactly are the nature of the roots, you know. So thank you so much, guys, for tuning in. Thank you for watching the video. Please do remember to subscribe. You can remember to like, and please I would appreciate it if you interact with me and you tell me what you would like me to work on for our next video, because I know you guys are on school holidays. You'll be opening soon, so just any chapter that is ahead of us, let us start doing it now and be ahead. It's gonna make things easier when school opens. Thank you so much. I'll see you on the next one.